Chapter 1, Lesson 2, Precalculus, looking at the next characteristics of a function when analyzing, and in this video we're going to look at asymptotes. And we did cover these last year a little bit, but again, as review, the asymptotes can be horizontal or vertical, and these are parts of a graph where the graph appears to flatten out. So the graph comes down, it flattens out. It doesn't cross, it doesn't go down, it just kind of appears to flatten out. And this can flatten out as it's going vertical or as it's going horizontal. The asymptotes provide what we call limiting behavior for the graphs. Limiting behavior of the graph. In other words, it limits where the graph can go. If you look right here at this section right here, you'll notice as it comes down towards this horizontal asymptote here that the graph kind of flattens out and it gets very close to this line, and but it never actually touches the line. This line here limits where the graph can go. And these again can be horizontal or vertical. You'll notice if you're looking at the graph coming this way, you have this vertical asymptote here. The graph kind of flattens out as it gets close to this limit or it gets close to this asymptote, but never actually crosses it. So asymptotes provide what we call limiting behavior to the graphs. It kind of gives the boundaries of the graph and where it can go. Now, these asymptotes provide limits to the graph, like I said, so we're going to introduce something new. So this is probably the only, one of the new things that we're talking about in this lesson that you probably haven't seen before, and it's a calculus thing, and it's called limit notation. And it's a way to describe the behavior of the graph at these horizontal or vertical extremities. In other words, what happens way out there at the ends of the graph, way out at positive infinity or negative infinity, if we're talking about horizontal, or vertically, what happens is these graphs go up and down. And this limit notation allows us to read it. Now I want you to take special notation. This is our special note of this notation. You read this as the limit as x approaches positive infinity. Okay, this is called limit notation. And it's describing what happens to the graph, what is the limit to that graph as the x values get higher and higher and go up toward the positive end of the graph. They can also look at the limit as we approach the negative end of the graph. So the limit as x approaches negative infinity. As the x values go towards negative infinity, so those x values are going to negative 100, negative 1,000, negative 1 million. What is the graph doing as it goes out that way? Okay, so this is a way to describe what the x values are doing. The answer or the limit that you give will be what's happening to the y values. Okay, now these next two, the limit as x approaches a from the right and from the left, we won't use those until later in the year, so we won't do a lot of talking about those when we're talking about asymptotes for right now. Okay, so that's new notation, and then we will do a few examples so you kind of see how that's written and how we're going to use that. Now, we're talking about asymptotes, so we want to figure out where these asymptotes occur. How do we figure out where these asymptotes are going to be? And this is something that we did late last year, so again, it'll be a little bit of a review hopefully, but if not, write these down and then we will do a number of examples. The vertical asymptotes, so where these vertical asymptotes are, how do I find them? You look for the zeros of the denominator. Now remember, this word zeros we talked about earlier. The zeros of the denominator are the values that would make the denominator 0. Okay? If the zeros of the numerator are in common with a 0 of the denominator, in other words, they're both the same number, then you're going to create a hole in the graph or an asymptote. Most of the times it's going to be a hole. And again, we're not going to do a lot with these graphs at the beginning of the year as far as graphing them. We're just going to be looking at these as we analyze the graphs. Okay? Remember, that's the focus here, is analyzing the graphs. Now, the horizontal asymptotes, if you remember, how do we figure out where that one is? We have three scenarios. And we have to look at the degree of the numerator and the denominator, and we're going to compare those. And based upon the comparison, that will tell us where the asymptote is. If the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is at y equals 0. if the degree of the numerator is equal to the degree of the denominator, then you take the coefficient of the leading term in the numerator over the coefficient of the leading term in the denominator. Okay? And finally, if the numerator degree is greater than the denominator degree, then there is no horizontal asymptote, but there is another asymptote. Now, there's something very special about asymptotes that we're talking about here that I want you to pick up on. It has to do with the horizontal. We call this a horizontal asymptote, but actually a more accurate name would be the end behavior asymptote, because what this horizontal asymptote does is it really limits or controls what the graph does out at its ends, way out at positive infinity and way out at negative infinity. It's not an asymptote like the vertical. The vertical asymptote, the graph cannot cross it. It cannot go over it. So in that respect, the vertical asymptote limits where it can go vertically. However, the horizontal or the end behavior asymptote limits what the behavior can do at the ends. But in the middle of the graph may cross that horizontal asymptote. So unlike verticals, the horizontal asymptote can be crossed, but out at the ends it cannot be crossed because it's an end behavior asymptote, so it limits what the graph can do out at its ends. That's why an end behavior asymptote would probably be a better name, and that's the name that you'll see as you go throughout the book. The end behavior asymptote, we're talking about a horizontal asymptote. Alright, so that's all I'm going to do about talking about the videos, or talking about asymptotes in this video. In the next video, we'll do some examples, and then we'll show you how to write the limit notation in that example video as well. So make sure you check out the example video next.